Okay, so let's add a little about the harmful algal blooms, or as they are known by the experts as HABs. Looking generally at the impact of anthropogenic warming and increase in CO2 on water bodies. The most direct impacts are, of course, warming and acidification. CO2 dissolves very easily in water, so that reduces the pH and makes the waters more acidic, which have a whole series of consequences, especially for corals and other calcifying animals, which include some of the HABs. Warming also increases stratification. Stratification is the layering in the vertical. In general, the ocean has warm waters near the surface and a sharp temperature gradient called the thermocline, and fairly constant temperatures down to the deep ocean from about 1 kilometer below. You can find my podcast on that on this channel as well. Stratification getting stronger basically means the gradient getting stronger, so the energy required to mix the colder waters into the surface layer becomes harder. And there are more nutrients like nitrogen and phosphorus and iron in the cold waters below. We're not going into the details, so mixing that nutrients into the surface layers also becomes harder. Why is that important? Because near the surface layer there is light, and if you provide nutrients you can have photosynthesis. Okay, so that becomes harder. So primary production, or like on land we have vegetation and other primary producers that give us food. Ocean also has the base for all the food chain in the ocean that is related to photosynthesis. Human activity also produces lots of nutrients into the ocean and coastal oceans and lakes and so on. Agriculture, for example, urban runoff from lawns and so on and so forth. And these conditions can also generate harmful algal blooms. Some species are better at competing in warmer temperatures, low nutrient conditions, or excess nutrient conditions, and so on. And to meet the fisheries demand, there is also now lots of aquaculture, especially close to coastal regions, which is a concentrated production of fish and shrimp and so on, which also feed the fish to make them grow faster and get bigger, fatter, etc., which has also lots of problems on the water quality, etc. So from that general background, we will see that harmful algal blooms in inland water bodies like lakes and so on have generally increased. Here is the legends. So blue and the greenish colors are where the harmful algal blooms have decreased. The P less than 0.1 and P greater than 0.1 are confidence levels in the signals we have detected. Are we 99% confident or less than 99% confident in the signal? In general, you can see that there are more of this red and magenta-ish color around the world, including high latitudes into the Arctic Circle and the Great Lakes and Lake Victoria, Tana, Turkana, and other lakes here, or India and Asia and so on. So there has been impact of human activity, land use change, urbanization, warming, agriculture, and so on the abundance of harmful algal blooms over time. Okay, this is a book chapter by Clarissa Anderson, who is now at the Scripps Institute of Oceanography, from a book, and her chapter title is Living with the Harmful Algal Blooms in a Changing World, and is looking at paralytic shellfish poisoning from 1972 to 2011. It says 1970 here, but 72 here for whatever reason. Nonetheless, you can see that there were well-known paralytic shellfish poisoning on the US West Coast into Canada and Alaska, and a little bit up here in Canadian East Coast as well, and some in Europe. But by 2011, you can see that the number of paralytic shellfish poisoning cases have expanded across the globe, especially along the Asian coast here, Australian coast, all the way into the southern tips, Africa, South America. So none of the coasts are left behind. So PSPs are typically associated with marine dinoflagellates. Flagella is a little thing they use to navigate. So these are kind of phytoplankton. They're called Alexandrium and Pyrodinium. These are some of the species which produce something called saxitoxin, a dangerous neurotoxin that makes its way into the food web and can be lethal. Okay, so this is not just something that you eat, you get diarrhea, and then you get better. This can actually kill you. Okay, can make breathing harder and so on. Here is a table from the same chapter by Clarissa, talking about human syndromes caused by ingestion or exposure to marine HAB toxins. I'm not an expert on this, but from what little I know, things like brevitoxin by Carinia, for example, gets aerosolized, which means along with the sea salt, it can get picked up into the air. So even if you are just walking on the beach, you can actually get affected. That's what it means in cases like exposure. Okay, so there are ciguatoxins, saxitoxins and its derivatives, domoic acid. These are the so-called syndromes. Azisperacid and its derivative, brevitoxin, ocodaic acid, and there are a few more like yesotoxin, coleotoxin, and so on. I'm not going to go into the details, but the causative organisms are listed here. Alexandrium, we already mentioned, pyrodinium, gymnodinium, pseudonychia, which is one of the things that Clarissa works on a lot, produces domoic acid. This is one of the few diatoms that is actually a harmful algal bloom. And domoic acid causes something called amnesic shellfish poisoning. So people can become forgetful or get dizzy and disoriented. And the old story is that in the 1960s, I think there were a few birds in Santa Barbara area that ate shellfish poisoned with domoic acid, which can happen during an El Nino, for example. And they went crazy, and there were reports of them attacking people. Now, do you remember a movie where birds attack people? It's called The Birds by Alfred Hitchcock, right? Apparently he was vacationing there, heard the story, and made a famous movie out of it. There you go, directly from marine biology to a Hollywood movie. So symptoms go from nausea, vomiting, diarrhea, numbness of mouth and extremities, rashes, tingling, and what else is new here? Severe cases can result in seizures, cardiac arrhythmia, respiratory distress, coma, and possibly death. Not good, right? So we have to obviously watch out for increases in harmful algal blooms, not only with global warming and stratification and acidification, but also other human activities which increase nutrient loading, especially in coastal waters, because the agricultural activities and urbanization, lawns in the great suburbia can produce fertilizer and pesticide runoffs into waters, and excess nutrients tend to cause algal blooms, typically things like red tides, which are also harmful to human beings. And they can also cause massive fish kills. There are many places where there is natural upwelling, like Benguela coast here and Somali coast here, for example, have very strong upwelling and produce blooms and anoxia and hypoxia. So when you have excess nutrients, it's called eutrophication, and the bloom of the phytoplankton can be so large that the zooplankton cannot eat them up, so the phytoplankton die and drop to the deeper parts, where aerobic microbes graze on them, and aerobic means they use up oxygen to consume this food, so the dissolved oxygen levels in the water can drop below critical levels like 5 micromoles per liter, I think 5 milliliters per liter, or 2 milliliters per liter, and they become hypoxic and anoxic, which can end up killing many of the benthic organisms like shrimps and crabs and so on that cannot run away. Okay, so some of these favor harmful algal blooms, which apparently can compete better when you have these kind of conditions that are adverse for some species, but they do pretty okay. So human health is seriously affected by harmful algal blooms, and there is plenty of indication that global warming and other human activities are making them worse, and obviously that also affects the fish that we eat, so we have to be careful about those as well.